Hello, this will be a demonstration of Proposition 1 from Book 3 of Euclid's Elements, which states simply to find the center of a given circle. All we are given then is a circle ABC, like so, and then it is necessary to find the center of this given circle ABC. First, we shall join the straight line AB, which you can do by postulate 1. Next, we shall bisect it at point D using proposition 110. Then, with 111, from point D, we shall draw the straight line CD perpendicular to AB, like so. Next, we shall produce CE down to E, like so. We can do that by postulate 2. Finally, we shall bisect CE at this point F. Now, I say that this point F is the center of the circle. For if it is not, then some other point, let us call this point G, is then the center of the circle. Given this, we shall connect these straight lines GA, GD, and GB. Do that by postulate 1. Now, because AD is equal to DB, because we made it that way, we made point D such that AD and DB are equal. Next, we know that GA and BG are equal because they are both coming from the center of the same circle, and so they should be equal by definition 115. Now, using proposition 1.8, we have two triangles where three sides are equal to three sides. And so we can say, for example, that the angle GDA is equal to the angle GDB. And because these are adjacent angles, by definition 110, they must both be right angles. Now we also know that the angle FDB is a right angle, because again, we made it such in the first step when we made CD perpendicular to DB. And so by postulate 4, that all right angles are equal, we can say that the angle GDB is equal to the angle FDB. Now, the angle GDB is equal to the angle FDB, and because it is a part of the larger angle FDB, it must also be less than it by common notion 5, that the whole is greater than the part and the part less than the whole. And so the angle GDB is simultaneously equal to and less than the angle FDB, which is obviously absurd. And so the point G must not be the center of the circle. Similarly, no other point but point F is the center of the circle, and therefore the point F is the center of the circle. Therefore, the center of the circle ABC, namely point F, has been found QEF. Now, there's a porous into this proposition that states that from this, it is manifest that if in a circle, a straight line cut another straight line into two equal segments and at right angles, the center of the circle is on the cutting straight line. What this looks like is something like you have a circle and you have a straight line in it. And you have another straight line cutting it such that it bisects it and is perpendicular to it, then the center is somewhere on this straight line. Now, that is the end of proposition 3.1, and so I will end the video here and move on to proposition 3.2.